Okay, let's dive into this. Welcome back, Focus Learners, to another explainer. Today, we are unpacking something absolutely huge. We are looking at a truly groundbreaking document that just dropped on June 4th, 2026. Basically, Anthropic has pulled back the curtain on one of the most closely guarded secrets in the tech world. We are getting a look at exactly what happens inside a frontier laboratory when artificial intelligence starts, well, writing its own code. It's a fascinating look at the raw internal data of an accelerating technological shift, and I am so excited to guide you through exactly what this all means. To truly grasp the magnitude of this shift, we are going to use a micro to macro approach today, starting with the granular engineering data and zooming all the way out to global treaties. So our roadmap looks like this. 1. When AI builds AI. 2. Engineering and research accelerated. 3. The human experience. 4. 3 possible futures. And 5. The call for coordination.
All right, let's jump straight into section 1, when AI builds AI.
To lay the groundwork, what exactly is this document that's making such massive waves right now? Well, the source material is a 25-page research paper titled When AI Builds Itself. It was written by Marina Favreau and Jack Clark from the Anthropic Institute, which, if you remember, is the think tank the company launched earlier in 2026 to study the broader impacts of their tech. Now, what makes this explainer so absolutely critical is that Anthropic is bringing unprecedented internal engineering data into the public eye. They're making concrete, factual claims about AI's accelerating capabilities. We aren't talking about theoretical sci-fi anymore. This is current reality.
Moving right along to Section 2, Engineering and Research Accelerated.
So, this is where the theoretical rubber really meets the road. We're going to look at the hard, undeniable engineering numbers that anchor this entire report. Now, what's really interesting about this statistic is how stark and, frankly, unbelievable it is. As of May 2026, over 80% of the code merged into Anthropic's production codebase was authored by their own AI Claude. Over 80%. Let that sink in for a second. The majority of the infrastructure that is building the next generation of artificial intelligence is literally now being written by artificial intelligence. And what's even more breathtaking is the sheer velocity of this transition. If we just look back to February 2025, which was right before the launch of Claude Code, the amount of AI-authored code was in the low single digits. So this monumental shift in software engineering, going from mostly human to 80% machine, happened in a mere 15-month window. As a direct result of all this, by the second quarter of 2026, a typical Anthropic engineer was merging 8 times as much code per day compared to 2024. Now, the paper candidly notes that, sure, measuring lines of code is an imperfect metric, but the directional trend? Undeniable. Obviously, engineers aren't suddenly typing 8 times faster on their keyboards. Rather, their roles have fundamentally changed. Claude writes the code, while the human acts more like the director and the reviewer. To make this data completely tangible, the paper details a very specific example involving a persistent class of API errors. An engineer actually estimated that a human would have needed 4 solid years to complete this fix. Why? Not because any single fix was incredibly difficult, but because the cognitive load of holding that much unfamiliar code in a human brain at one time is literally impossible. But when Claude was pointed at the exact same problem autonomously, it shipped over 800 individual fixes and reduced the error rate by a factor of 1,000. We also see this massive reduction in turnaround time in live incident responses. Imagine a routine upgrade completely crashing tens of thousands of training jobs. Typically, it would take a human engineer 2 to 3 days just to diagnose and fix that. But in this case, Claude was pointed at the live incident with minimal context, managed to isolate the specific debugging flag causing the crash, and confirmed a fix in about 2 hours. So the crucial point is that this acceleration isn't just happening in routine, everyday coding. It's happening in highly complex research. Anthropic runs a benchmark where they ask an AI to optimize code for training a small model. Back in May 2025, Claude Opus 4 achieved a 3x speedup. A skilled human researcher grinding for 4 to 8 hours usually hits about a 4x speedup. But by April 2026, the restricted Claude Mythos preview model achieved a staggering 52x speedup. The AI is now drastically outperforming human researchers in these optimization execution tests. Okay, let's pivot to Section 3, the human experience. With crazy numbers like that, what is it actually like to be a human working inside this lab? The paper includes these anonymous quotes from Anthropic staff, and they capture an incredible duality. This quote right here really highlights the optimistic side of the coin. For people whose jobs are fundamentally about having ideas, having a tool that implements and tests those ideas an order of magnitude faster is an absolute superpower. And it's not just a feeling. An internal poll of 130 staff showed they estimated a 4x increase in their overall research output thanks to this exact dynamic. But immediately following that, the paper presents a rather jarring emotional juxtaposition. This pessimistic quote illustrates a profound existential whiplash. Think about it. When the machine does everything better and faster, your human contribution suddenly feels minimized. And worse, when the highly automated system inevitably breaks, the humans realize they no longer fully understand the codebase they are supposedly in charge of managing. It's a really powerful look at the psychological toll of hyperautomation. Let's move to and see how this builds into Section 4, 3 possible futures. Zooming all the way out from the individual human experience to the trajectory of humanity itself, the paper outlines 3 potential futures based on this internal data. Future 1 is simply that the trend stalls, progress slows down, and core human judgment remains an unautomatable bottleneck. Future 2, which, by the way, Anthropic views as the most likely in the near term, is where the trend compounds, but humans manage to stay in the loop. In this reality, a 100-person company can operate with the output of a 10,000-person organization. And then there's Future 3. Full recursive self-improvement. This is where AI systems design and refine their own successors without any meaningful human involvement at all. And this quote brilliantly illustrates exactly where we currently stand. While the technical execution, the optimization, the bug fixing, all of that is rapidly being automated, our current safeguard is human direction and taste. We are still the ones seeing the bigger picture. But as you can imagine, as we move deeper and deeper into Future 2, the human role narrows strictly to that oversight. Finally, that brings us to Section 5, the call for coordination. Bridging the gap from granular engineering to global policy, we really have to look at the macro-level proposal that Anthropic insists the world must face. Neutrally looking at their argument, they state that a unilateral pause by just one laboratory achieves essentially nothing. If one leading lab just stops development, it literally just changes which company or country becomes the front runner. It doesn't solve the safety issues, it doesn't solve the oversight issues, it just shifts the power dynamic. Therefore, they argue a much broader deliberative process is required. The paper calls for an incredibly complex international coordination effort. They are proposing multi-party, verifiable agreements structured very similarly to global arms control treaties. This would require clearly defined triggers for a coordinated pause and strict mechanisms to avoid quiet defection. But as the paper readily acknowledges, doing this is incredibly difficult. Think about it. Monitoring and verifying the energy usage of random server farms is vastly harder than flying a satellite over and counting physical missile silos. The incentive for someone to secretly keep developing AI to gain a global lead is just enormous. Which leaves us right here. The data shows that the engineering acceleration is undeniably real, and the transition from humans writing code to AI building itself is well underway. The question the paper ultimately forces us to ponder is this: is the world truly ready to coordinate an international AI arms control treaty before Future 3 arrives? It's a staggering thought, and one we all need to deeply consider as this technology continues its exponential climb. Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.